Welcome, and today we're diving deep into artificial intelligence. Specifically, we're looking at some ideas from Eric Schmidt shared at TED. Eric Emerson Schmidt is an American businessman and former computer engineer who was the chief executive officer of Google from 2001 to 2011 and the company's executive chairman from 2011 to 2015. So really thought-provoking stuff from Eric. And here's the main thing Schmidt said is that AI, despite all the noise, all the hype, it's actually underhyped, which sounds counterintuitive. So our mission today is to unpack that. Why does he think it's underhyped? Let us explore the big implications, the dilemmas it throws up for us, and maybe try to picture the future AI could build, an astonishing future potentially. So to really get why he's saying this, let's rewind a bit back to 2016, the AlphaGo moment. This kind of quiet but pivotal moment. You've got this ancient game Go, 2,500 years old, deep strategy, very complex. And then AlphaGo. This AI makes a move no human player in all that time had ever conceived of. It's pretty mind-bending when you think about it. And the how is fascinating. It wasn't about intuition like a human master. AlphaGo was basically built to always keep its odds of winning above 50%. Just calculating, pure relentless calculation. And through that, it found this move. For Go players, these are brilliant strategic minds. It must have been shocking. It raises a fundamental question. How can a computer create something genuinely new in a game we've played for millennia? A move we never thought of. And that, you could argue, is where this current AI revolution really kicked off. So that was the spark. So is it really underhyped? I think for most people, AI equals ChatGPT or, similar language models. And they were impressive, that ability to talk, to write, even with some mistakes. It felt very real, absolutely visceral. But that was, 2 years ago now? Time flies in AI. And the big leaps since then aren't just in language. They're in reinforcement learning, the kind of thing AlphaGo pioneered. It allows AI to do really sophisticated planning strategy. You look at systems now like OpenAI's O3 or DeepSeek R1. They're doing this deep back and forth planning. These aren't just quick answers. Schmidt mentioned systems spending like 15 minutes writing complex papers. That's a lot of processing. It shows the shift, from language to maybe sequential stuff, like in biology designing proteins. And now to this really complex, multi-step planning. His vision is AI agents basically running almost all business processes. Agents like little AI workers. Imagine an agent for one task, another for the next, all linked together. Concatenating, he called it. Communicating with each other. Communicating probably in English, mostly to run huge operations pretty much autonomously. It sounds incredibly powerful, but also incredibly demanding, computationally hungry. That's the perfect way to put it. And that leads directly to the roadblocks, the limits. The number one limit, Schmidt says, is energy, plain and simple. He gave this startling figure. In Congress, he said the U.S. needs another 90 gigawatts of power, some 90 new nuclear power plants, and that's staggering. We can't just build those overnight. It's just not feasible with current construction rates, not in the short term. Software gets more complex, more demanding, and this planning AI is even hungrier, way hungrier. He said planning increases the compute need by like 100 to 1,000 times compared to earlier AI. This is so because you're going from deep learning to reinforcement learning. And then there's this thing called test time compute. It's like the AI isn't just planning its next move. It's constantly learning while it's executing the plan, refining its whole strategy in real time. So it's learning and doing simultaneously at massive scale. It's the ultimate computational demand. Huge energy implications. Problem number 2, the data wall. Data wall meaning we're running out. These huge models have devoured almost all the high-quality human-generated data out there on the public internet. So what happens is that AI systems will have to start generating their own data to learn from synthetic data. But does that work? Is it as good? That's the challenge. Quality control, avoiding biases baked into the generated data. There's a whole new set of problems. Problem number 3, maybe the most profound one. It's about the limits of knowledge itself. Current AI is amazing at finding patterns within a field, but it struggles to do what, say, Einstein did. Take a tool or concept from one area and apply to a total different one to create something fundamentally new. So it's not truly inventing like humans do those big leaps. Not quite yet, it seems. The technical term he used is non-stationarity of objectives. So let's break that down. Think of it like trying to win a game where the rules keep changing as you play. AI is brilliant with fixed rules, but real invention, real discovery, often involves changing the rules or seeing connections across different rule sets. Solving that problem will probably means even more data centers, more energy. But it could also unlock entirely new ways of thinking, new scientific paradigms. That's the really transformative potential. As we get closer to that, though, this idea of AI acting on its own, it becomes a really big deal. Yoshua Bengio, for example, a pioneer in the field, called for halting development of these agentic AI systems, systems that can act autonomously, systems that can pursue goals independently in the real world or online. And Bengio's concerns are very legitimate. Schmidt respects the concerns deeply, but argues stopping isn't really practical, because it's a global race. If one group stops, others won't. His focus is instead on building strong guardrails. Guardrails like safety measures. He uses an analogy: humans are agents. If an AI agent starts acting weirdly, maybe invents its own language we can't decipher, what do? His answer: unplug it, because you don't know its intent. Could be good, could be bad. You need to be able to understand what it's doing. So observability is key. Provenance, he calls it being able to trace back how it decided something, what actions it took. Transparency. There seems to be some industry consensus emerging on this, things like recursive self-improvement that spins out of control, like AI improving itself too fast for us to keep up, or AI getting direct access to weapon systems. That's a clear no-go. And also, systems that start copying themselves or sending data out without permission, exfiltration, or unauthorized reproduction. So the idea is, let the research continue, but build these safety switches, these guardrails, very carefully. That seems to be the approach Schmidt advocates: robust guardrails. This naturally leads us into the whole geopolitical dimension. AI isn't just lab tech. It has real-world power, and that includes the military side, the dual-use dilemma. Dual use meaning civilian and military applications. It's a major ethical challenge. The US military, for instance, has its 3000.09 rule that basically mandates human in the loop, or meaningful human control over lethal systems. Schmidt sees that as a critical line not to cross. But beyond specific rules, there's the bigger picture, the US-China competition, which Schmidt says is the defining competition in AI right now. You see it in things like tariffs on tech components, US restrictions on selling advanced chips to China. That's a big deal for China. Apparently, it's their number one concern in those informal Track 2 dialogues, access to the most advanced chips. China has leaned more into open source, like with DeepSeek. Their efficient algorithms became available. And guess what? The US benefited immediately. So China's open approach helped the US. In that case, yes, the US tends to favor closed, proprietary models, partly for control, partly IP. Schmidt raised an even bigger, almost existential concern linked to this race. He talked about the network effect in the race to superintelligence. AI is smarter than humans in basically every way, and the network effect means a small lead becomes huge fast. Imagine being just 6 months ahead. The improvement curve is exponential. He painted this picture of AI creating its own programmers, millions of AI programmers generated from thousands of human ones needing only electricity. So the leading side could just pull away incredibly fast. And the fear is, if one side gets super intelligence first, the other side might think they could destroy us, which leads Schmidt warned to legitimate people, saying the only solution to this problem is preemption. Preemption like a first strike, potentially. He used the phrase bombing data centers. That's incredibly stark. He stressed that foreign policy hasn't really grappled with this yet, and it might be coming into view within, say, 5 years. That's a very short time frame for such a massive potential shift, and it brings up that open source question again. If it's so dangerous, why advocate for it? He acknowledges it's one of the wicked hard problems. The whole tech world, academia, it's built on open sharing, so you can't just shut it down. Not easily. The current thinking, he says, is that today's open source models aren't yet a national or global threat, but they could become one. You can see the path which makes the decisions by the US and China and the big companies absolutely critical right now. And he really sees it as just those two players in the lead. He argues only the US and China have the sheer capital and compute resources to really drive this vision forward at scale right now. So it's a defining global battle. He mentioned Dr. Kissinger worried about an accidental escalation like World War I stemming from this kind of intense competition. It's a heavy thought, and it connects to another tension trying to prevent misuse, trying to avoid dystopia, stopping non-state actors getting dangerous AI, but potentially building a massive surveillance system in the process, the 1984 paradox. So how do we maintain control without too much control? How do we keep our values? Schmidt emphasizes sticking to societal values, preserving freedom. He warned that even well-meaning engineers could accidentally build systems that restrict liberty. So it's a design choice, a values choice, a business decision ultimately rooted in values. He also touched on identity verification. Because of misinformation in bots, proof of identity online is becoming more necessary. But crucially, he says it doesn't have to mean giving up all your personal details. How will it work? Cryptography. Things like zero-knowledge proofs they let you prove we're a real human. or over 18 without revealing who you are or your exact age. So technology itself might offer solutions to some of the problems it creates. That's the hope balancing security and privacy. Schmidt is also quite optimistic. He talks about the potential good. He paints a picture of radical abundance. Take healthcare, for example. Imagine AI helping eliminate major diseases by identifying all the druggable targets in the human body, or slashing the cost of drug trials. Imagine AI doctor assistants fluent in every language available globally. Universal healthcare access, essentially, that's the dream. And in science, maybe AI can help us find dark energy or discover new materials for incredible transportation or scientific tools. As for education, personalized tutors for every child, from kindergarten onwards in their own language, making learning engaging, maybe even gamified. And socially, he mentioned tackling loneliness, something that's paradoxically grown in our connected digital age. These are solvable problems, he insists, solvable without needing new breakthroughs in physics, just the will, the resources, and the AI tools to do them. It sounds almost utopian. So are we all just going to be lounging around while AI does everything? He pushes back hard on that. He says fundamentally, humans are unchanged. Lawyers will find cleverer lawsuits. Politicians will find new ways to spin things. Our basic human nature, our drives, our flaws, they remain, so it's not a post-work paradise necessarily. But he does see a massive economic shift. He mentioned falling birth rates globally. That's a trend everywhere, which means we need the existing workforce to be way more productive to support everyone. And AI could be the key. He cited one study suggesting agentic AI and AI-driven discovery could boost productivity by maybe 30% per year, which is unprecedented. Totally unprecedented. He said economists literally have no models for that kind of sustained growth. It's never happened. So the arrival of AI, then AGI, then general intelligence, then superintelligence. He calls it the most important thing that's going to happen in about 500 or 1,000 years. And it's happening now. His simple conclusion, don't screw it up. Easier said than done. Maybe. His core advice is surprisingly grounded. He says, think of it as a marathon, not a sprint. He used an analogy from doing 100-mile bike race. He learned about spin rate. Just keep pedaling steadily every single day. Keep going. Don't get overwhelmed by the sheer scale. And because the growth is exponential, things change so fast. What was true 2 or 3 years ago, you'll forget because the reality will be completely different. So constant adaptation. His ultimate wisdom is ride the wave every day. Don't think of AI developments as isolated events. And what does riding the wave mean practically for you, listening to me right now? It means whatever you do. Artist, teacher, doctor, business owner. You need to be adopting these tools rapidly. Because those who don't, he warns, risk becoming irrelevant compared to their peers, their competitors who are using AI. For example, he mentioned something called the Anthropic Protocol. For businesses, it means their AI models can now plug directly into their existing databases without needing complex middlemen or connectors. It removes a whole layer of complexity and cost, offering huge flexibility, that kind of fundamental operational shift. He says things like that are happening daily now. Daily changes, fundamentally altering how things work. That's the pace we're at. The pace is just staggering. It feels like we're truly in the middle of something historic. Which leaves us maybe with a final thought for you to think over. In this world where AI is said to accelerate discovery and change at this unprecedented rate, what new kinds of human creativity, what new forms of collaboration will we need to invent ourselves, not just to coexist with AI, but to truly complement it? And that's it for today. My name is Alex, and thank you for listening. Bye for now.